Hey, this is the final assignment for Math 043, and with this assignment, what I've chosen to do is review the first four assignments, and I had to cut it off somewhere just because the length of this assignment was getting pretty long. So I've reviewed the first four assignments, and I've just pulled a few questions from each topic that were on those assignments. I'm going to go back through them. It is my hopes that in this assignment, you just get a quick refresher. If you come to a problem that you are just too confused about or just don't understand, you can always refer back to the previous assignments. All of these questions were evaluated in the previous assignments. I posted the solutions, I made videos for certain problems. So please refer back to those. As always, you can contact me if you have questions about this. But the intentions of this assignment are just to give you a quick refresher on things that we covered at the beginning of the semester. I don't want to overwhelm you. I do expect you to do the even problems. I'm going to try to do all the odds. I expect you to do the even problems and submit it. But the main focus this week at the end of the semester should be preparing for your Math 143 exam that's coming up. So I'm going to jump into this, and hopefully I'll go through these as quick as possible. Hopefully the introduction was the longest thing about this assignment. So the first example is turn a fraction into a decimal. So all you do on this one is grab your calculator, type in 3 divided by 8, and it gives you the decimal 0.375. So anytime we're asked to turn a fraction into a decimal, we just simply divide that in our calculator. Next one is I want to turn the fraction into a decimal, and I want to round. So here I'm asking to round to the nearest hundredth. This was just to show you that sometimes these decimals will go on forever. So if I do number 3, 3 divided by 7, press enter, I get this decimal, 0.428571429, and then my calculator runs out of space, but that value actually keeps going forever. But if I say round to the nearest 100th, that is 3 decimal places. So I go to the third decimal place, look to the right, that 5 tells me to round the 8 up. So this would be 0.429, and that would be my solution when I'm actually having to round. So there's a difference between an exact answer and a rounded answer. Next, we looked at mixed numbers. So if I want to turn a mixed number into a decimal, and I'm not going to pull the calculator up, I'm just going to show you in writing how I'm going to type this in. I'm going to open parentheses, and I'm going to do 5 plus 7 divided by 8. And that is the same thing as 5 and 7/8. So I grab my calculator, 5 plus 7 divided by 8, and I'm going to close my parentheses. And the calculator actually that I'm using showed up this way, which is fine. 5 plus 7 divided by 8. And that gives me the value 5.875. So for mixed numbers, you simply add the whole number to the fraction. And for a fraction, we just simply use the division key. For number 7, decimals into fractions. With this one, there's a button on our calculator that we should have used by now, and it's just going to convert a decimal to a fraction, and it's going to be different for every calculator. So once again, I'm just going to do this in my calculator, and hopefully this is a refresher video. If you are stuck on this or have lost this button, go back to the original homeworks where I demonstrate this. But I have 0.25, and if I punch that in my calculator and turn it into a fraction, I get 1/4. For number 9, I have a whole number with a decimal, right? So that's 1.1 or 0.1.1. It looks odd, but if I type that in, I get 1 and 1/10, or depending on the way your calculator is set up, I have 11/10. So this is called an improper fraction, and I say improper fractions are allowed. This is the mixed number. So depending on how your calculator spits it out and what guidelines the instructor gives you, you can use either answer depending on if improper fractions are allowed or if the instructor wants it as a mixed number. All right. The next set, we were adding and subtracting. So just keep in mind, once again, a fraction is just a division. So if I type this in, I do like to put parentheses around it. So I'm going to do 3 divided by 8 plus 4 divided by 8. And that would give me 7 divided by 8 when we type it in our calculator. If you wanted to do this by hand, which I would encourage you to try to do, but for your test, make sure that you're also double checking yourself on the calculator. As long as we have a common denominator when we're adding fractions, we're just adding the numerators. 3 plus 4 gives me 7, and I keep the denominator, which is 8. So for 13, it's the same thing. I have 5 divided by 12. That would be the fraction 5/12 minus 4 divided by 12 is how I would type it in my calculator. And that would give me 1 divided by 12. Once again, if I have a common denominator and I'm subtracting, I'm just subtracting the numerators. 5 minus 4 gives me 1, and then I keep the denominator, which is 12. All right, so when it comes time to add and subtract mixed numbers, here you'll see I have mixed numbers, and I also have unlike denominators. So here I'm really going to encourage you to just go ahead and use your calculator. I need to type this in as a mixed number, which would be 1 plus 3 divided by 8. Close your parentheses. And then plus, so once I've closed my parentheses, I have a plus. And then I'm going to open my parentheses back up, and I'm going to do 2 plus 5 divided by 6. And you can hear me on the calculator over here. And I get this number, 4.2083333. And if you look at my instructions, I'm asking this answer to be written as a mixed number. So here's where you're going to want to convert your decimal to a mixed number. Some calculators will handle that all by itself. Some calculators, you're going to have to realize that the 4 is your whole number. So I'm going to subtract 4 from this, and then I'm going to be left with this decimal, and then I can turn that decimal into a fraction. Which I would get 5/24. So once again, I do realize in this video I'm not showing you the calculator steps. That's because this is just a review. It's just a refresher. If you're ever stuck on these, refer back to the original video for the original homeworks for this section. All right. Next thing we covered was multiplying and dividing fractions. And this one you can really do by hand, but once again, for your test, always double check yourself on the calculator. But when you're multiplying fractions, you're simply multiplying the top. 3 times 4 is 12. And you multiply the bottom, which gives you 64. Now, for your test, you're probably going to be asked to simplify it. So if you do it by hand, make sure that you simplify that. 12 divided by 64, and you can press enter and then turn it into a fraction again, and that would reduces to 3/16. So anytime that you can use your calculator for your test, I encourage you to do so. It's always good to know how things work by hand, but double check yourself and make sure you're reducing everything if you do it by hand. With a divisions with fractions, if we try to do this by hand, was the keep, change, flip rule. We keep the first one, we change the division sign to a multiplication, and we flip the second fraction. So then I would multiply across the top because now I have a multiplication, which gives me 20, multiply across the bottom, 10, 20 over 10 reduces to 2 in this case. Once again, your calculator could have handled that as a division. If you're using your calculator, you don't need to keep, change, flip. The calculator is going to do that all by itself. You just type in 4/5 divided by 2/5. You're just going to want to make sure that you have parentheses around those. Okay, so now we looked at word problems. The first word problem is if there are 600 people at a baseball game, 3/4 of them are pulling for the home team, how many total fans does the home team have at the game? So anytime you're either given a percentage or a fraction of an entire amount, so here I'm looking to find out what is 3/4 of 600, I'm just taking that fraction and I'm going to multiply it by 600. So if I grab my calculator, type in 3/4 times 600, I would get 450. So anytime you're looking for a fraction and you have the total amount, you just multiply the fraction by the total amount. Same thing would go with percentages. All right, so next we're looking at converting decimals to percentages. Now remember, this was a common step in the interest problems where we were given a rate and we had to go from the rate to a decimal. So we're working the opposite way, but we do need to know how to go from decimal to percent as well. So to go from a decimal to percent, the general rule was just move the decimal 2 times to the right. So if I move that decimal 2 times to the right, I have 25, and that would be 25%. Same thing with number 25, 2 times to the right, that gives me 325, and now that's a percent. 27, grab the decimal, move it 2 times to the right, that gives you 3.8, and that would be a percent. All right, so if going from a decimal to a percent, we move 2 times to the right, and then we put the percent sign. The next stage, if we're going from a percent to a decimal, and this is the one that's used more common, is you go 2 times to the left. The issue with this is the percent doesn't, or the decimal doesn't always show up. So if the decimal doesn't show up, it's at the end of the whole number, to the right of the whole number. So if this was 2%, I put the decimal to the right of that and I move it 2 times to the left, and then I have to go in and add my zeros. So this would be 0.02, and it's not a percent anymore, it's a decimal. Same with this one, 2 times to the left, so that would be 0.0325, and once again, it's not a percent anymore, it's a decimal. 33, 1, 2, so that gives me 0.00038 as my decimal. So to go from a percent to a decimal, we're moving the decimal place 2 times to the left. Very similar to the word problems we just did. Here I have a percentage of a total. So here I have 600 people at the baseball game. 20% of those are pulling for the home team. How many total fans does the home team have? So with this one, anytime you're looking for a percent of a total amount, you do the same thing that we just did with the fraction. I have 0.20. First, I need to convert that to a decimal, 0.20, as I've done, and then multiply that by 600, and you should get 120. So 120 people are pulling for the home team. All right. One of the next assignments, we looked at dimensional analysis, and I started with some very basic ones that we could probably do in our head without using this technique, but then I get into some harder ones, which you're definitely going to need to use this technique. I'm going to cover a couple examples here. So 4 feet to inches. The basic example is take the starting amount, 4 foot, and make it a fraction. And then I need to multiply this by something that's going to cancel out feet. So if I had feet on top, I need feet on bottom. And then I look up here and I see that I have this converting unit. 1 foot is 12 inches. So the word feet will cancel, and I'm happy because I have inches, and that's what I wanted. I wanted inches. Once you get that, you multiply across the top. 4 times 12 is 48. Multiply across the bottom. 1 times 1 is 1. 48 divided by 1 is simply 48. And the unit of measure you have is inches. So that would be 48 inches. 39, 24 inches to centimeters. So I'm going to start with 24 inches. I'm going to multiply it by something that gives me inches. I'm going to look and make sure that I have this in one step, and I think I do. 1 inch is 2.54 centimeters. So I have 1 inch is 2.54 centimeters. Inches would cancel. I'm happy because I have centimeters, so I'll multiply across the top. 24 times 2.54 gives me 60.96. The bottom again gives me 1. It's not always going to be 1. So I have 60.96, and the unit that did not cancel out was centimeters, so 60.96 centimeters. 68 inches to feet. This time I'm going from a smaller unit to a bigger unit. So this time I have 68 inches. I make it a fraction. Inches on the bottom, and I do have one that goes from inches to feet. I have 12 inches is 1 foot. So the word inches would cancel. I'll multiply across the top, 68 divided by 12, and then I'm going to grab my calculator. I think I was letting you round in this one. I'm going to round this answer. If I wanted to keep it as a fraction, I could just reduce the fraction, but this is roughly rounded to 1 decimal place, 5.7, and my unit of measure that I have left is feet, so 5.7 feet for that one. All right, and then we got into multiple step conversions, which this one you really need to write out and use dimensional analysis. Here I have 4 feet, and I want to go to centimeters. So when I start with 4 feet, I do not have a unit that goes from feet to centimeters. So even though that's what I would want to do, I can't go there quite yet. But what I do have is 1 foot is 12 inches. So now I've successfully canceled out the word feet, but I need to cancel out the inches. So I know I need inches on bottom because I don't want inches. I want centimeters, and I do have one that goes from inches to centimeters. It's 2.54. I did that the wrong way, and hopefully you will catch that if you did. It's 2.54 centimeters is 1 inch. So now inches have canceled, and I would multiply all the way across the top, which I have 4 times 12 times 2.54 gives me 121.92, and across the bottom I would just have 1, so that would be 121.92 centimeters. All right, 68 centimeters to yards. I'm starting with 68 centimeters. I know that I have 2.54 centimeters. I'm going to use the same one I just did. 2.54 centimeters is 1 inch. I know that 12 inches is 1 foot, and I know that 3 foot is 1 yard. So I've canceled out centimeters, I've canceled out inches, I've canceled out feet, and I'm left with yards, which is what I wanted. So now I can multiply all the way across the top, and I would get 68. Multiply all the way across the bottom, and I get 91.44. Don't round until you get to the final answer, 68 divided by 91.44. If I'm allowing you to round here, that was roughly 0.74 yards when you do 68 divided by 91.4. All right, multiple step conversions with rates here. When I see 2 miles per hour, that means I need to set up my initial one as 2 miles per 1 hour. So here you'll see I have a unit on top and a unit on bottom, and I want to go to inches per minute. So if I want to just focus on miles to start with, and how do I go from miles to inches? I have to first go from miles to feet. So I have 1 mile is 5,280 feet. Miles would cancel, and then I want to cancel out feet. So I have 1 foot is 12 inches. Feet cancel. All right, so I have inches up top, which is what I wanted. So I'm happy there. And now I just need to convert hours to minutes. So if I want to cancel out hours, it needs to be on top. 1 hour is 60 minutes. And now I can cancel hours, minutes. And this is going to leave me with my answer in inches here over minutes. So inches over minutes. And I'm not going to do the math on this one just because I can sense this video is getting a little long. And it's not my intentions for y'all to spend a lot of time on this video since this is all review material. Standard conversions in higher dimensions. This one was a unique one. So here I'm starting with square feet and I want to go to inches. So I still want to think of it as feet, but I'm going to think of it this way. It's 4 feet squared, and I'm going to put it over 1. So the conversion that I have from feet to inches is 1 foot is 12 inches. But if I leave it as this, I have feet squared on top and just feet on bottom. So to counter that, I'm going to square this second fraction. So now if I rewrite this, I have 4 foot squared over 1. That was my first fraction over here. And then I'm going to multiply this. When I square this, I need the square to top. So that gives me 12 squared is 144. And now it's inches squared over 1 squared is still just 1 feet squared. So now feet squared have canceled. And 4 times 144 gives me 576. And that would be inches squared. 1 on 1, 1 times 1 on the bottom would just give me 1. So that would just give me 1 on the bottom. So that's how we take care of higher dimensions. If we're dealing with squares, we would just square that first conversion. If we're dealing with cubics, we would cube it, which means raise it to the third. So that one's a little tricky. Feel free to go back to the section for all those. All right, it should move a little bit quicker now. We talked about scientific notation and how to just write it as a standard decimal form. So if I see 10 to the positive 5, that means I'm moving this decimal 3.4 and I'm moving it 5 times to the right, which means I would have 4 zeros, which would give me 340,000 is the same thing as 3.4 times 10 to the 5th. 3 times 10 to the 4th, I start with 3. I grab my decimal. My decimal is always behind my number if I don't see one. 1, 2, 3, 4 means I'm adding 4 zeros, which gives me 30,000 for this one. 55. This time I'm moving to the left because that's a negative 3, so I'm starting with 9.7, and I move 1, 2, 3 times to the left. So that means I need to add zeros in front of the 9 this time. So I have 0.097. Feel free to always add a 0 in front of the decimal. If you want to, you don't have to. All right, so now I'm taking something that's in standard form, or just what we would view as a traditional number, and I'm converting to scientific notation. So what we want to do is we want to have 1 digit to the left of the decimal, and I evidently had, yep. All right, so I want to make this 1 digit to the left of the decimal, not to the right of the decimal. So what I mean by that is if I'm starting 3, 5, 4, 8, and I have a decimal, I only want 1 value to the left. So this would be the value 3.548. And then I had to figure out how did I get there? 1, 2, 3 times. I moved it 3 times, so I need to raise this or multiply this by 10 raised to the third. So this is 3.548 times 10 to the third. If you always work backwards, if you did the scientific notation, you should end up with 3,548. So same thing here. How many times did I move? 1, 2. I moved 2 times to get there. So I have 3.17875. Since I moved 2 times, I'm going to multiply that by 10 raised to the second. 61. I'm already there, so I don't need to do anything. And that was kind of a tricky one. I just need to make sure I count 2, 4, 5 zeros. And that would be 10 to the 1, or I'm sorry, 10 to the 0, because we didn't move anywhere. So that would be the same thing as multiplying this by 1. Or you can just say this is already in scientific notation. 10 to the 0 is the same thing as 1. Slightly tricky one there. All right, and then the last section that I'm going to discuss in this assignment, at least, is metric conversions. I first started with the saying King Henry died drinking chocolate milk, or using this number line, and then I taught you a more mathematical way to do it. But if I'm going from kilometers to decimeters, kilometers are here, decimeters are here, and I was simply counting 1, 2, 3, 4 times to the right. So I grab my value, I grab the decimal, and I move it the same direction and the same amount of times, and then I go back and add zeros. So this would be 120,000 decimeters. All right, 12 kilometers is 120,000 decimeters. Same thing here. I have 1.2 millimeters. This time I'm starting here, and I want to go to decimeters, so I'm moving 2 times to the left. So I grab my decimal, go 2 times to the left. So that gives me 0.012, and that would be a decimeter. And then the more mathematical approach was, all we're doing is subtracting exponents. So if I'm starting with 12 kilometers, kilometers is here, if I could find it. Kilometers is here, which the exponent is 3. And I'm going to decimeter, which is here, -1. So if I take the exponent, 3 minus the exponent, -1, that gives me a distance of 4, or a difference of 4. So I'm just grabbing the value 12, and I'm moving it 4 times to the right. So positive values would move to the right, and you would see that I would get that 120,000 that I got a while ago when I did the same problem. Same thing with 69, 12.58 millimeters. So I'm going to erase what I have up top, just because I have different values. This time, millimeters is here, which is 10 to the -3. So I start with -3, and I'm going to decimeters. So I'm going to -1. So -3 minus -1 is the same thing as -3 plus 1, which gives me -2, which -2 means I need to grab that decimal and move it 2 times to the left. So if I do that, I have 0.1258. And my pen's not writing, sorry. And that would be decimeters. All right, and that's going to be it for the review. I did accomplish this in under 25 minutes. I realize this is a pretty lengthy video. I also realized that I did a lot of verbal talking and not a lot of writing of the math for all of these. Once again, my intentions are just to get a refresher on this. I do want you to do all the all the even problems for this assignment. I do want you to submit it. My main focus this week is not for you to focus too much on Math 043. You do need to review the foundations in this class, but my main focus is for you to focus on your Math 143 final exam.